Great. Thank you very much, Chris. Thank the LED for giving me the opportunity for this, and thank everyone in attendance. Good morning, good afternoon, good evening, depending on the time zone you're in. This webinar, we're going to talk about TPM, but it's more than just painting and labeling machines. We're going to discuss a little bit more detail as far as what you can do and I've got someone right here beside me, but anyways, we'll go ahead and dive in. This is a little bit about me. I'm a lean manufacturing specialist for Greif Incorporated. That's an industrial packaging company. I was previously worked with medical device manufacturing, worked with in the construction industry, logistics. I've got a BS in engineering management from the University of Missouri at Rolla. I'm a senior member of ASQ and SME. I was past treasurer for ASQ Lean Enterprise Division, and I've moved on to become a member of the Lean Certification Oversight and Appeals Committee. Among other things, I've got a number of different certifications through ASQ, currently Lean Bronze certified, and I'm co-editor, co-author of the Lean Handbook through the Quality Press. And of course, that's a better looking picture of me, just the same with less gray. So as far as TPM, when we're in our organizations, we basically hear a lot of the same things. We're late to shipping, the machine broke down, it runs pretty well most of the time. It's a temperamental machine, but the operator, we know all the tricks. It's down again, and this is just a headache after headache. So what does that trigger us to do? Usually triggers us to do some sort of TPM event. So we gather people around and we start doing things like, hey, we put a fresh coat of paint on the machine, make it look a lot nicer, a lot newer. We might even replace some major components that we know have wore out over time. We might even do a little bit of 5S activities around the machine, and just make sure that people know where spare parts are, understand where the tools are to use on the equipment. And we might even go as far as throwing in some checklists, some visual management on the equipment, do some labeling on it, and usually we'll see a pretty good spike in or improvement in productivity on the machine short term. But what tends to happen long term, we end up seeing that eventually the machine state goes down, downhill. We kind of lose some of the improvements that we initially had. We have operators and people in key positions that change within the company, and we lose some of that general knowledge. So we ask ourselves on face value, when we had that event, what really changed? What did we really do to make it sustainable outside of maybe possibly some visual management and some checklists? We might even throw in a little bit of standard work, but did we really change the culture that fosters an environment for stability? And in order to do that, I'll touch on a little bit of this subject and transition back to TPM. But you can't really talk about lean without talking about cultural change. And cultural change, we as lean leaders, we are trying to change the hearts and minds of the organization. And we look at it from such that the hearts of our organization is our machines, regardless if it's a factory or an office environment. The machine, the equipment, that's the heart of the organization, and people are the brains. If we want the whole body of the organization to be healthy, it takes both of those to really function hand in hand to be a healthy organization. So on cultural change, on culture within the organization, we really have to focus on creating an environment where there's patterns that we can practice. Because as we talk in in Shingo, we discuss in the Lean certification body of knowledge. We talk about it in the Lean handbook. It's all about cultural change and what we can do to create that cultural change. So what those have laid out is it takes practice patterns that we have to practice over and over again to form habits, because as we form habits, we end up creating behaviors, and through creation of behaviors, we drive cultural change. And this is the premise behind the Shingo criteria, behind the lean body of knowledge. It's this habits to behavior to culture. And we know if we ever have to get rid of a bad habit, we have to practice and have the discipline to create new habits that are better to fill in and overcome bad habits. And that's how we build this culture. And like I said, that's a completely separate webinar, and can talk quite a bit in regards to that topic alone. So in regards to culture, what we've lined out is there are two key principles to enable culture, enable cultural change, and those two principles are respect for the individual and humility, and those relate directly to TPM. We must place focus on the brain side of the organization, or on the human side, to succeed in the cultural change, and that is also true with regards to TPM. So focusing back on TPM, there's really 6 basic principles of TPM. The minor defects, those are root causes in which most equipment failures come from, and so we've got to drive a focus on completely eliminating all those minor defects. And the way I describe minor defects versus major defects is minor defects are those things that can be handled at the shop floor level, or things that are everyday occurrences or nuisances, versus those catastrophic or major defects of, failure of components, things of that nature. Properly planned maintenance routines can prevent almost all sporadic equipment failure, and we all pretty much know that from reliability-centered maintenance programs and maintenance department initiatives. However, cross-departmental teams can actually advance equipment performance improvement at much greater ease than just a single department alone. While we see maintenance departments do a terrific job, and we have some very skilled personnel in those departments, if we really want to take it to the next level, that's that cross-developmental team that requires maintenance, engineering, and manufacturing, the shop floor itself, to really advance the performance of our equipment and processes. And then continuous learning is at the heart of continuous machine improvement. As we say with Lean, it's the seeking of perfection, so it's about continued machine improvement with TPM, that focus. And the machines are effective preventive maintenance programs make more product than machines that are only repaired when they're broken down. That's a statistical fact. Any reliability engineer can bring those statistics to the table. If you're going to take care of your equipment, we know it's going to work for you. And then effective preventive maintenance plans, those do require less time from our technicians, where we can have them spend their time doing improvement activities rather than firefighting. So we really, the principle is to take our engineering staffs off of being firefighters and really put them on projects and activities that are going to improve the organization as a whole. So with TPM, it really consists of two components: the maintenance program, or the maintenance department itself, and the autonomous maintenance side. And we're going to focus on the autonomous maintenance side within this webinar. I'm not going to talk too much on the maintenance program side, the maintenance department, the engineering side. That's pretty much set. But a lot of the focus when it comes to TPM activities is what can we do on the shop floor, and that's because autonomous maintenance is really that it refers to the independent activities that are performed by the operators, by the individuals on the shop floor. And don't say I'm a manufacturing guy. I've worked a little bit in service, so when I say shop floor, this can be related outside of manufacturing within service industries. I mean, even any kind of technical industries. We've got computers, we've got printers. Some people still work with fax machines and things of that nature, but those pieces of equipment are the hearts of the service or hearts of the office, and you know, when those go down, granted, there's a lot of different things outside of what a person what a user can do with that technology, but there are things that we can do to maintain that equipment and prolong the life and the reliability of the equipment. But again, autonomous maintenance, that's those activities outside of a maintenance department. In the office, it may be those activities that users can handle outside of an IT department. So those activities can be anything from daily inspections, lubrication, parts replacement, simple repairs, precision checks on the equipment, things that these individuals can be trained to do and to do properly. So for this reason, we'll focus on the autonomous maintenance side because this really deals with the people side of TPM. So TPM, in a sense, is a paradigm shift. I mean, we've got the old attitude of the operator saying, I just operate the machine. Maintenance guys, you fix it. We've got engineering saying, this is the way we've designed it. You just need to operate it that way. But TPM, really, the system of TPM, the maintenance side, the technical theoretical side, the engineering side, the whole design side of equipment, working hand in hand with the manufacturing, the operations, the shop floor, the user side, and it's a system that has to work together because everyone is responsible for the equipment. So what that does is it transitions maintenance supporters or the maintenance department, the engineering department, that staff into more of a supporter service. So think of them more or less like doctors, in the machines or the equipment as the young patients or the kids, and think of the owner operators, those the operators themselves, the owners of the equipment, as the parents. You know, if the kid breaks their arm, you're going to take them to the doctor. If the kid gets a scrape on their knee, the owner operator, the parents, is going to put the Band-Aid on the knee and not call the doctor. So the goal is the health of the machine. So while the owner operator is responsible, the maintenance supporter is strictly a partner in that relationship and called upon in extreme or specialty circumstances. The reason why we as parents don't fix a broken arm with our kid is because we don't have the technical skills or the medical skills to set a broken bone. So we call on those experts, and that's really the relationship that we're trying to drive here with TPM between owner operators and maintenance supporters, because at the end of the day, we want a nice, happy family and not necessarily the owner operator choking the machine itself. And just a little humor on Homer Simpson is always good for a little bit of a laugh and a break in the monotony of technical discussion. So back on track with autonomous maintenance. Really, the process of creating an autonomous maintenance environment, it's a 6-step process, and it's a continuous process. It's much like Plan, Do, Check, Act. It's like continuous improvement. We're continuously going through this process over and over again and improving each step within the process. So we usually start out with the clean and check. This is typically the TPM events that we're accustomed to. We go in, We clean the equipment, do a thorough cleaning, we check it out, we see what parts need to be replaced, and then we move on to the second step, and each step should build upon the other. Anything that we've seen within the clean and check step, we eliminate minor defects. We address inaccessible areas of those areas that can't be reached or can't be easily inspected or cleaned. And then from that information that we gather from the first two steps, we start creating standards regarding cleaning standards, inspection, lubrication, and then we move on to the real meat of TPM, and that's the operator skills training. So we've created these standards, we've identified all these potential minor defects, address these inaccessible areas. We've identified how we clean the machine, how we check it, and now it's time that we really use opportunities to train the operators and give them this knowledge, this technical and theoretical knowledge from a machine design standpoint, and teach them the why we do what we're doing, or why that we're asking them to do these things, because it's all in context of keeping the machine healthy. And then 5 is actually the conduct the autonomous maintenance activities that are defined. And then the last step is that visual management, the improvement. And it's really a focus on how do we make all of the other steps involved in the autonomous maintenance process more efficient. I'll describe those a little bit later. So step 1, cleaning really serves 2 purposes. It removes contamination, which usually is a high driver of machine wear and machine failures, but it's also a very good opportunity to inspect machine components. So how exactly how an operator cleans the machine, it gives them that opportunity to really inspect the equipment with a detailed eye. Because that next step is really taking this opportunity for cleaning and checking the equipment, is to teach these operators about root cause problem solving. So asking those questions, okay, where did this dirt or where did this dust, where did the oil come from? How can we clean this machine better, and really get them involved in a lower level root cause problem solving activity to develop those patterns of root cause problem solving within them on a daily basis. Because we're really, again, we're trying to teach a pattern, new patterns for them to evolve themselves on this continuous learning lean journey. So while we're not necessarily just teaching them wax on, wax off, we're telling them all the information that they need. What are we doing it? When are we doing it? Where it happens, how it happens, and why. Those are important, because the method and inspection, those methodologies need to be taught and why they're important. Because training development opportunity for operators comes few and far in between. We've got to find ways to take them and apply it outside the classroom, and walking through those standards and taking those opportunities to really teach them some of the methodologies. It falls back on some of the Toyota Kata methodology, using that time during your work day to train them and provide them new opportunities to develop good habits that evolve the culture. So from step 1, the clean and check, we've really taken and we've done a thorough inspection of the equipment. Now we want to take that extra step and say, okay, we need to start eliminating some of these minor defects. Now, contrary to past experience, a typical focus on TPM has been those big hitters. It's been, what are those massive machine failures that we need to address? And that's really not, from my experience and some statistics that I've ran over the number of years, the real meat comes from addressing those minor defects, those contaminants, those the dust, the dirt, the things that can be taken care of on a daily basis that is well within the skill set of an operator to be taught and to give them the knowledge to take care of. And the reason is most of the machine failures, when thoroughly investigated, can be contributed to a root cause that's related to a minor defect. Because minor defects, any single minor defect can cause a variety of machine failures. Minor defects are continuous. In other words, they continue to deteriorate the machine if they're not addressed. So if uh, dust gets into wheel bearings and things like that, it's not going to cause an immediate failure, but it's going to deteriorate and cause wear and tear on the machine, which compounds and causes other failures later on. Which brings us to the other aspect, and it can impair equipment. Minor defects can impair equipment performance and accelerate the deterioration of other components of the machine. Now, I've seen this multiple times where we've get pneumatic cylinders or hydraulic cylinders that have contaminant issues. Either the lubrication's bad, or we've got water in the lubricant, or dirt and dust, and we'll have a cylinder that starts hitting extremely hard. And typically with just as an example, we had an electrical component on a piece of equipment that continued to fail, and we were looking at it from the perspective that, well, maybe it's an electrical issue that we have in that area. And what was actually occurring after a long duration of root cause problem solving, we found that the cylinder was actually a cylinder on the machine was causing shock vibration, which resulted in failure of the electrical component because of contamination in the pneumatic system for the cylinder. So it was hitting a lot harder, even with soft stops. And we're getting into technical engineering type stuff with machine design, but that cylinder, while the minor defect was contamination, uh, that cylinder was causing a component failure on a completely unrelated piece of the equipment. And that brings us to the last part about minor defects is, minor defects can combine and cause and interact with other defects in very random ways, and there's no method to the madness until you figure it out, and then you can connect the dots. But there is no straight troubleshooting regarding minor defects unless you have that history, that machine history and the environment history to break down those troubleshooting guides, which is part of this TPM process. So also regarding step 2 is addressing inaccessible areas. While we're addressing these minor defects, we also need to address these areas. And typically this step comes in is an improvement from the previous slide. We address the minor defects, the leaks, things of that nature. And typically what happens is when we get to step 6, and this will all come together at the end, but we get to step 6 and we'll get into this visual management and this improvement. Well, how can we do things faster? How can we make cleanability of the machine better? Well, we start putting things in place like clear plastic covers over things, or replacing plexiglass, or replacing machine guarding with plexiglass so operators can see inside the machine without entering the machine, so they can perform a certain autonomous maintenance check of the machine itself, and getting cords and pipes and hoses off the floor, or bundling them up so the machine can be cleaned easier. And it's all about making the process of autonomous maintenance more efficient. So that brings us to step 3. Step 3 being the standards part of of TPM. So all the lessons learned within step 1, what needs to be cleaned, how it needs to be cleaned. Step 2, what defects can happen. So now we're putting together this piece of the puzzle that, okay, we know what we need to do, we know why we need to do it, what we're trying to preventing. So we start putting together these standards. Now you can make standard work, you can do 1-point lessons, single point lessons, however you want to do it. There's no strict structure. I use standard work for a lot of these types of documents. Checklists work well as far as summarizing these documents and tracking whether or not these steps are done. But in essence, you create standards that, define frequency of the activities, any type of safety concerns that you have to address, add in pictures. But as far as cleaning is concerned, it's what you clean, how you clean it, where you clean it, how often, any type of PPE that you may be required, because you do get in some circumstances where you've got specialized chemicals or special things that you have to clean, especially within machining operations that I've been involved with. Is while we didn't want maintenance to come in and replace the coolant, because we're replenishing a coolant within this manufacturing machining operation so often, that needed to be an operator function. But because of the type of coolant, there was a possibility of skin irritation, skin reaction. So we need to train the operators on proper usage of PPE in those instances. So you address those kinds of that. I use that example in cleaning standards, but there's also lubrication standards as well that we have to address. And in those instances with regarding lubrication, now all machines with motion have some sort of lubrication system, manufacturing, even within some of the electronics, some of the technology, copiers, anything with motion has some sort of maintenance regard. Whether we may not be putting oil directly into a copier, but there are certain things, certain components that we have to look out for as far as lubricating and keeping the machine moving as designed. But with the lubrication standards, and I took a lot of this from basically a presentation that is a 2 or 3 hour long class presentation that I provide for maintenance technicians and operators undergoing a TPM initiative or maintenance excellence initiative within my company. So based off that, we really get into a lot of details regarding lubrication, the standards, inspections, all the different types of technical knowledge that's needed. So I'm going to try and stay on track and not get off onto tangents and some of the details regarding a lot of the technical aspects of what kind of lubrications and standards that we should use. But we address a number of things that aren't necessarily what is called within the operator's knowledge threshold, but is important for autonomous maintenance activities. So just using lubrication as an example, there's a number of different types of lubricant contamination that they need to be aware of. We've seen a lot of the color coding that goes along with different types of oils, just so we have that somewhat mistake-proofed. Even with oil cans, you got some oil cans that have different diameters versus others, so you don't put the wrong oil in the wrong orifice on the equipment. You also have we have quantity considerations that we have to take into account. I can't tell you how many times, and even as my grandfather farming growing up would take a grease pump and just pump grease into a wheel bearing on a tractor until he saw grease come out of the sides of the bearing. Well, the technical knowledge behind that and why it's wrong is each bearing is specifically designed to have a certain amount of lubricant, and if you squeeze lubricant outside the bearings, what's going to happen? Well, that's going to just collect dust, dirt, contaminants. So there's a lot of technical aspects as far as how much lubricant, how often do you need to put into certain design components of a machine. That those aspects have to be trained, have to be taught to the operators that are going to be performing these activities, because they have to understand the technical side of their equipment if we're going to make them owners of the equipment. Which brings us to, there's other inspection standards. So if we're going to require them to do a certain inspection, and this is an example of a machining operation, for an operator to adjust a coolant level. Take a maintenance department that has a bunch of machinists in there, but then we took that machining operation and we put that into a manufacturing environment where it's actually a production piece of equipment. It's a completely different monster. You've got operators that have zero machining experience running a machining operation. So you have to give them the technical knowledge. And this is an example of an inspection standard for a coolant operation. Hey, as water evaporates, and coolant is essentially, in some machining operations, it's coolant and water mixed together at a certain concentration level. So we have to give them the knowledge to be able to, how do you measure coolant level concentrations, and then what do you need to do to replace the coolant to reach a certain concentration level. And any type of inspection that has to be done that's been outside the scope, general knowledge of the operator, those should be covered as part of the TPM activities. So that brings us to, once we've got the standards in place, the standard work in place, the activities, operational standards, we move on to the operator skills training, and this is really the meat of TPM. You need to take every opportunity you can to increase the knowledge, increase the knowledge, increase the skills of the operators, because we should be taking the time to teach them how to inspect, how to be able to detect slight abnormalities with the machine, because we want them to, who better understands their kids more than their parents? So we want them to be parents in that parent-child relationship and really know their machines inside and out, as well as they know their kids. So we want that to transfer that equipment knowledge from the maintenance department, from the engineering groups, to the operators, so they understand the why and not just the how. When a machine is making a certain noise, they understand, well, this is what's happening, this is why. Well, this is a little different than what I've heard in the past, and be able to react to those changes in the environment. And those training opportunities can come from anything from general machine inspections during a TPM event, walking through with the maintenance. One thing that I've been involved with is having vendors come in. I mean, we are we as organizations are often hounded by all these different vendors for different components, spare parts, things like that. Well, let's take advantage of that and bring them in for these lunch and learn sessions, and have them give product demonstrations and really teach maintenance people that that needs that information, as well as the operators. Bring them in for lunch and learn, and let them learn about a component inside and out from the people that make the component themselves, from the vendors. There's always the classroom training, but if they're trying to learn about the equipment, it's better to be out there at the equipment. And then, going on some past webinars, the kata experimentation. I mean, the best way to learn about something is to experiment with it, and if you have those opportunities to experiment with the equipment, those are great opportunities for operators to learn. So I don't know how many times I've seen an piece of equipment break down, and what we do, we send the operators off to do some cleaning, or do do some sort of other activity or even leave for the day if it's a catastrophic breakdown. We'll take those opportunities for those operators to stay with the equipment, be with the maintenance staff to really understand, okay, what happened, how we repair it, give them that knowledge uh, to implement at a future date. And this is a perfect opportunity if we're transferring this knowledge. Single point lessons work quite well in this instance. There's a lot of things that you're trying to teach people, and if they're not going to use them day in and day out, well, you're going to have to find a different method. And I've seen some websites, and you guys will have my contact information, has numerous single point lessons, especially around reliability centered maintenance, TPM type activities. So please, by all means, contact me, and I'll provide you the website links. But there's literally hundreds of single point lessons out there that address anything from electric motor maintenance, how to use a temperature probe, how to use a laser light alignment for motors and belts. And these are things that can be taught not only from a maintenance standpoint, but also from an owner standpoint on their equipment. If a belt slips off, they've got to recover from it, but you don't just want them to throw on another belt. You want to make sure that the belt's aligned properly, because that will create defects down the road if you have those misalignments. So things such as the theories and design behind pneumatics, hydraulics, how do you inspect pipes, how do you inspect hoses, electrical wiring, how do you double check those types of components of the equipment. There's tons of single point lessons out there to help those operators have that knowledge when they have to perform those activities. So once they're adequately trained, step 5 is that actually go out and conduct the autonomous maintenance. And this is where you start looking at the layout of the equipment, what is the best route around the equipment. And we start getting into this. All right, this is what you do day in and day out. This is basically the route around the equipment you take. Where do you need to look? What do you need to look at? What are you looking at? And basically taking those standard work documents you've created, and you're really doing a cell layout, but for the autonomous maintenance side of TPM. What activities do you need to perform, and where do you need to perform them, and what you're performing them on. And you can create a standard work document just for the autonomous maintenance inspection. What are you inspecting, how you're inspecting it. And I provide these as simple examples. You can get very complicated, very technical in some of them, but a picture speaks 1,000 words. By showing them not only the equipment, but giving them some verbal description on what they need to do, where they need to do it at, and need to set them up into some sort of daily pattern to perform these activities on some given frequency. You have those that are only performed once a week, once a shift, every shift, once a month. It's all depending upon the machine that is being inspected, being managed from the operator aspect. And as they're doing this, as they're going through this autonomous maintenance inspections, this is where they can really start understanding, well, what can we do to improve the inspection itself? How can we make the inspection more efficient for us? Because starting out, those autonomous maintenance inspections can take them upwards of a half an hour to an hour, because it's things that they've never done before. So we have to be inventive, and that's where step 6 comes in. What can we do to help make this process more efficient? And this falls back on some of the things that I mentioned in step 1, step 2, regarding, the plexiglass, replacing guarding with plexiglass so they can see inside the machine, rather than removing the guarding every time that they have to inspect the equipment. When they have to inspect whether or not they've got looser bolts, using there's some they've got torque glue and things of that nature out there that you can mark a line across those bolts. Well, it's easier to see if if the two lines on the nuts are aligned, rather than using a torque wrench to make sure you've got the adequate torque on there, because you want these to be quick spot checks. Again, we'll get the visual maintenance. If they've got to turn dials, which way do they turn them? And again, all this adds up to even new employee training. So you get a new operator or a new employee to the organization, it helps them understand and a lot quicker as far as what they need to do and how they need to do those activities. Paint colored marks for checkpoints, uh, the ruler for the simple gauge when they're making an adjustment. Uh, Again, visual maintenance can go on and on, but uh, going back to those standards of inspection, uh, over to the right, you've got color code when to notice when a chain is in proper tension or not. That's a quick spot check that can be within the standard work on how an operator would detect whether or not they've got a loose chain and it needs to be addressed. Uh, the zebra stripes for fluid levels, I mean, those are great. Those work terrific for quick spot checks, because oftentimes those sight glasses, they are difficult to determine where the fluid levels are in those. Uh, and then you even take that to the next step, the improvement. And I'll use lubrication as an example. Uh, the uh, the lubrication systems that can be put in place to reduce the frequency uh, in how often you have to apply lube. You can put extensions on so it's easier to reach to. Uh, so you want to make these activities as easy as possible and as quick as possible, most efficient way for those operators. So just reflecting back from those 6 steps, what the process is actually doing is, at each step you take, you're doing a plan, do, check, act cycle, because you can always go back to the previous process and make improvements on how you clean. When you're going through and eliminating defects, you might spot that issue. Hey, this is going to be tough to inspect or tough to clean. We need to go back and reassess how we're doing the cleaning or the checking, and that can happen at any point in the process. That's why this TPM is not a single event type activity. This is a long-term activity that often takes, depending on the equipment, can take months and years to get to this TPM utopia state where everyone is working together and you've got true machine reliability. So I hope this sheds some light on autonomous maintenance side of TPM and how autonomous maintenance is a little bit more in depth than simple painting or labeling equipment. But again, thank you all very much, those in attendance. Thank you, Chris. Thank you, LED, for the opportunity to present this topic. Again, my email's on the screen if you would like some information on the links for those single point lessons or 1 point lessons regarding maintenance activities. Don't hesitate to drop me an email and I'll send that. I'll be more than happy to send that link. If you have other questions or comments, feel free to contact me. At this point in time, I will turn it over to Chris and see if anyone has any questions or comments.
All right. Hey, Chad, that was great. I especially love the very last part of that where you just tied that whole PDCA cycle, and this is not a one-time event. So thank you very much for that. Sometimes that's the biggest hurdle to jump over. So we have a couple of comments. Great presentation. We have one comment came in a little bit earlier, and I think it was when you were right about step 5 or 6, stating seismic activity adds to the TPM issues. If you want to comment on that.
Step 5, or the seismic activities.
Add to TPM issues. And if that's not making a quick connection for you where that was at or where you might have been talking, I will have Carol Elm, sorry, if you want to maybe elaborate on what you were referring to, that would be wonderful.
The only thing I'd hate to make an assumption. The only thing I can assume is if that's coming out of California or so, when you say seismic, that's that, and that's my old construction background. That's the first thing that comes to my mind. Oh, okay, I've got to think about earthquakes.
All right, so we'll look for some clarification if there is any from Carol. Gregory Morgan states or asks, can you provide insight on the duration of time it takes for a TPM journey from concept to full-blown program?
It it to be honest with you, speak like a true consultant here. It depends, but it really depends on the size and complexity of the equipment and how many parties are involved. I've seen massive automation uh, production lines across multiple shifts, a 24/7 operation where the complete TPM journey would took about, I'll say, a year and a half to get from, a fundamental maintenance department maintenance schedule to a full-blown owner operator. Operators have all the knowledge needed to address minor defects and minor spare parts and component replacement activities. The way it was set up is they started out with weekly meetings. Each shift had a certain number of individuals that were assigned to various modules of the line. So it really, for those complex activities, we had to break up the production line into somewhat mini machines, so to speak, based off modules of the production line. And the whole production line's an automated assembly, and just attack it in stages. But the beginning meetings, a lot of the hard work up front was addressing that clean, that check, addressing each component at the component detail level, and so that was a lot of activities up front. But then it was a matter of, you get to a point where I'd say within easily 6 months down the road, we got to a point where it was more capital investor on the modules to get to those next step improvements. So I would say you can easily, on any machine, probably turn it around within 6 months and get to that state. But to make sure it's sustainable, it's going to take a long time, because you're trying to get people to adopt to a different style of maintaining their equipment, and those patterns take time to form habits and behaviors and culture. But putting all the pieces in place for a solid foundation of TPM can easily be managed within 6 months uh, uh, for a machine that is of somewhat complex nature. I hope that gives you some insight, but it really depends on how much effort you want to put in up front too, because when you're resource constrained, that can really hinder your efforts. Some people might not be able to have those 1-hour weekly meetings where you're addressing a component at a time for each shift of operation. So it really is dependable upon your resources and how much you take. But regardless, speeding through, you tend to forget forget things, or you let things slip through the cracks. This is a long-term commitment. You're changing the organization basically one machine at a time, and we set priorities based off what machines what was our critical pieces of equipment, and those were the ones that we attacked first, and we spent the time up front to do just that.
Okay, so we have a response in regards to the seismic comment earlier, and yes, Chad, you were exactly correct. That's what we were talking about is earthquakes, and the other comment for clarification is that for them this must be somebody in a earthquake-prone zone. Above a certain number, we shut down the machine shop for equipment evaluation, and calibration is always of concern. It sounds like in those cases. So
Mm-hmm.
luckily for me, I don't have to worry about that, and hopefully never will.
Just thinking about, and that's also a valid point from the standpoint of, okay, if you are in an earthquake zone, there's a number of building codes and regulations that you have to meet. And I'm coming from thinking of it from a residential construction point, but think about a stove or something like that in a seismic area. You're typically required to have some sort of anchor on that stove to prevent it from tipping over during an earthquake. And there's same things with water heaters and things like that nature. Well, those are prone to the same wear and tear, uh, exposure to contaminants, things of that nature, to where you should have some sort of inspection process or maintenance process on those specific components of the machine. So yeah, I can see how that does definitely fits into TPM activities, because you do need to address those. You do need to inspect those on some sort of frequency, on some sort of basis, and you've got to give people the knowledge and skills to be able to perform that inspection, because there are reasons why we have those tie downs for those pieces of equipment. We don't want them tipping over. With a stove could be a gas leak, hot water heater could be a gas leak that starts fires. In after earthquakes, the major contributors is gas leaks, but you also have safety concerns where you don't want a shock, or maybe a forklift or something like that hitting a piece of equipment and tipping it over on top of an operator and causing a critical injury, or even death in those cases. So those types of aspects, I can definitely see those applying within TPM activities, and training operators the knowledge to be able to spot and inspect those types of components, treat them like components of the equipment.
And that brings up. I'm originally from Michigan, and for anybody that's watched the news, Detroit got hit really bad with some floods, and I would imagine wherever you're at with TPM, you've really got to look at the things that are in your own environment and make sure that you're considering those types of things: floods, water damage with water with electricity doesn't match no more than seismic activity with tip overs and gas leaks too. So you really have to make sure your TPM program concerns and considers those things.
And
Okay.
in my other presentation that I get into a lot of detail, I get into not necessarily for seismic or for regional type issues, but we'll get into a lot of that testing as far as ultrasonic testing. We get into a lot of the shock and vibration type testing elements that could be involved with TPM as well. So
Okay, so we are right at 12:30. We have just a couple of other questions. We have lots of great presentations, thank yous, wonderful examples, those kind of comments. So I want to make sure you hear that. A couple of questions. What diagnostic tools do you find work best on evaluating electric motor failure situations?
electric motor failure. So you're talking about the motor has already failed and you're sending it out. Typically, because I'm not in the maintenance department and I don't have a lot of that technical background, me personally, you can't go wrong with just sending it back to the vendor. I mean, they know their equipment inside and out. Uh, so typically, that's what I've seen at least the maintenance departments and engineering departments that I've been involved with, we typically, that's not our expertise, so we'll usually send that out to a vendor. And if you've got those relationships built up with your vendor, they will typically do a troubleshooting for you and get you some feedback, because I mean that's their reputation as well. But as far as, my main focus is, yeah, great. I'd love to. I try not to focus on the failure itself. I try to focus on failure prevention. So when you're talking about preventing electric motor failures, I'm looking at ventilation of motors. I'm looking at I'm looking at the proper motor rating for for the usage, for what the motor is being used for, and I'm also looking at thermal imaging inspection from the operator standpoint, being able to perform a proper thermal imaging scan and be able to detect when a motor is running hot, and that works just as well on electrical circuits too.
Okay, folks, we are right about 2 minutes after. There's just two more questions, so I'm guessing another 5 minutes, and we're going to keep going with Chad's permission. But I want to jump over back to my screen real quick and just go back to the slide that shows where this recording will be for anybody that joined a little bit late. The recordings will be available to you in about 3 to 4 days on the YouTube channel. Subscribe to that channel so that you get the notification. And then 7 to 10 days or so, we get it onto our ASQ Lean Enterprise Division website. So those are two places. And again, you will get your recertification email telling you that you earned your recertification units for those. So if anybody wants to hang out, and I hope you will, we've still got lots of people, we will go ahead and I'm going to jump back to the questions and let Chad answer those. All right. I'm going to get back to the screen, the right screen. Bear with me. All right. All right, next question. I guess there is a question and a comment. Melanie Davis says that they have a TPM program like this in place in their machine shop and wants to know if you have any recommendations on how the activities are recorded.
I've seen a simple well, for cleaning activities, I've seen something as simple as a dry erase or a magnetic board used. If it's, pretty much a standard cleaning, you just identify it's like a spot check. It's I have taken standard work on the different cleaning activities or the different inspection activities and basically itemized them, and then I'll take a checklist and basically for each activity gets a certain number designation, and then you get a checklist that has the number, a quick summary or title for that type of inspection, and then it's basically a check mark. So you can do it on paper, you can do it via a dry erase board, or a magnetic board works well if it's in a machine shop. So those are sort of the methods. If you're looking for document traceability aspects, of course you want a paper trail and you want to file those in some sort of manner. And when you get into pharmaceutical, medical device, some of those industries that require those activities to be documented, so the paper trail is nice. But if you're in I'll call it a mom and pop type machine shop where you don't have to have those heavy regulations in place, and you just want to make sure that those activities are being done on a day-to-day basis, you can use something as simple as a magnetic board to do that, just to make sure you will have that accountability, because that's really where that documentation comes into play. Yeah, it serves a regulatory purpose in those instances, but a lot of that documentation, the point that we're trying to get across is some sort of accountability to the operators, and that's where the leadership and the humility comes into play. We as leaders not only have to give them the knowledge and the skills and the trust to do these activities, but we also owe it to them to give them the tools to hold themselves accountable to perform it so they can keep up with. We're going to be asking them to do a number of checks, and that's where a simple documentation helps them hold themselves accountable so they don't skip those tasks. So it's really the whatever purpose that you're trying to drive from the documentation standpoint, whether it's regulatory, whether it's just trying to give them a tool to hold themselves accountable, how important those specific activities are. Some of them may not be as critical as others. So again, you have to balance that out with the risk of skipping versus the risk of uh, of documenting it over and over again.
And with that, we just have one last comment. Actually, another idea from Gregory Morgan in regards to that. He states that, for them, for their CILs, their clean inspect lubes, they use a dry erase board and a simple smiley frowny face visual on a checklist. And what I like about this is he also added that they have the next shift coming in grade what they did. So they kind of have a audit, so to say, to make sure that they didn't just really put it down and they really did the work. So great, love it.
Oh, awesome.
All righty. Well, that is all we have for questions. Lots, like I said, lots more good, great presentations. Wonderful. So Chad, thank you very much. I appreciate very much that you've taken the time to educate our members and given a little bit of yourself to pay it forward, so to say. So thank you. I appreciate your time. And with that, we're going to go ahead and conclude the webinar, and hopefully we'll see you all next month. Thank you. Take care.
Thank you.